Hi everyone, I'm Furkan and I'm developing a football game with my own game engine. In this video, I'll show you the brand new humanoid character model with cloth physics, along with the gameplay improvements like error-free running and better dribbling. Before diving into the recent improvements, let's recap the project's journey from my perspective as we mark its 1-year anniversary. I started this project knowing it's going to be a long run, and I'm pretty happy with the current state of the technical achievement, but I can't say the same thing for the release schedule. I imagined I could ship an early access version and improve it over time, but things didn't work as I expected. Combining a procedural animation system with a football game has indeed a good project idea to work on. I imagined I could pull off something big out of it, but packing things up became impossible when I noticed how the early gameplay looked so dull. So I went through exploring the physics-based animations in order to bring the dynamicness into the game. This was the choice that caused the game to take unexpectedly long development time to release, even a demo. But the ultimate support behind this choice was you, the audience. I got excited how much people are interested in the project. Then I said to myself, let's make it even more interesting. And step by step, I implement the necessary mechanics, dribbling with the ball, passing, shooting, and finally the goalkeeper. The next steps will be defined after deciding which path the game will take from the gameplay perspective based on the limitations. It's funny when you think about it, it takes more than 1 year to develop an MVP. And I'm still thinking this shouldn't be that way, but you know the story now. Before going any further, we need to play this game properly. So I started to revisit every corner and started to clean all the things up, because the project needs to be done as soon as possible. I tested that the body can have variable sizes of body parts. This will be needed to generate distinct characters. Simulation also works well with different and unnatural body proportions. The stick figure of the character has been around since the beginning, and it wasn't intentional. It is simply the easiest way for me to display the bones and joints. But this does not reflect the final image that I've been working for, so I replaced the body parts with a more humanoid shape with the Y-Bot model from Mixamo library. With the new humanoid character, I tuned the simulation parameters to help the body move error-free with any kind of input pattern. I can't say I completely solved this problem, because later changing something in the simulation code will result in breaking any carefully placed simulation variables. I explored some real-time parameter tuning or feedback loop by extracting the oscillation frequencies with FFT, but I got no result. I need a more sophisticated variable tuner, probably AI-driven. It was a great problem to work on, but I needed to move on for now. The next job is polishing the dribbling mechanics, just like the free movement. It's easy to apply a force to the ball as the character moves, but having full control of the ball while responding to the chaotic user input is definitely a great challenge. This problem involves understanding what the player wants to do with the input, and kicking the ball with right foot, with right force, to right direction. For this problem, I trained a simple machine learning model to project the character and ball movements. This increased the real-time performance with great accuracy. New approach helped in deciding how to dribble the ball when the character is in a state with the combination of different speed and orientation. I also constructed a ball-following mechanism. The end goal was creating a seamless change between states like free moving, receiving ball, dribbling and kicking the ball. When this is completed, I'm expecting to see multiple dribblers passing the ball around very soon. I decided it's time to fix the rigid foot by making it bendable. There was lots of feedback about this, and I know it is really distracting. I added a simple 2-bone skeletal animation structure to the foot model, and in real time, I modified the bone angles to synchronize the foot with correct surface contact. This feature significantly improved the visual realism. While working on visual improvements, I decided to add the real improvement by synchronizing the character with a skeletal animation model. 2 years ago, I was doing a similar development, which is synchronizing a ragdoll with a model. This time, I got it done without too much hassle. I chose the most suitable character model from the Mixamo library. After tuning all the joint parameters, finally our character has become a real human. I also added more rotational work in the simulation which became visible after the humanoid model. This includes the transformations of the spine parts, head, shoulders, and arms. The arms also got new movement sets which are raising or lowering them to help the body balance. Now while taking a shot, the body leans against the ball and raises the arms with correct swinging direction and timing to complete the famous action. I was genuinely amazed with the result. I was like, how's that even possible? It's still far from perfect, and I only know it can get better from there. Skeletal animation was done, but the character still didn't quite look like a real football player. The first thing needed to be done was adding the short with cloth physics. I revisited the idea of how cloth physics has been done in video games. Apart from the goal net, this time the cloth needed to collide with the leg constantly, and most importantly, it needed to be always on top of the collider surface. Even little mismatch is not tolerable here. After multiple attempts, I found a solution to keeping a cloth piece out of the collider surface successfully. From there, I created the short and t-shirt models with their simulated parts. When tackling tough problems, it's easy to get discouraged. I found that reflecting on my journey helps me see progress and stay motivated. Yet, challenges persist, and maintaining productivity is the key. Anyone looking to develop better strategies for staying productive can find some valuable classes on today's sponsor, Skillshare. Skillshare is the largest online learning community for creatives, with thousands of classes led by industry experts. With learning paths, curated sequential class collections, you can dive deep and master specific skills, taking your career or hobbies to the next level. Skillshare offers a wide range of creative classes, from digital art and illustration to graphic design, animation, film, and productivity. For example, Thomas Frank's Mastering Productivity class teaches you how to build a personalized productivity system to boost your efficiency and achieve your goals. The first 500 people to use my link in the description will receive a 1-month free trial of Skillshare. Get started today. I'm in the rapid development phase. I'm collecting every bit of things to be done in order to accomplish the quality I promised. In the next video, you might see multiple football players passing the ball around and making a shooting practice with the goalkeeper. This brings us the question of how the actual game is going to look like. I wonder what your expectations are from the gameplay perspective. Do you imagine controlling a single player or controlling all the players in the team? I would like to hear your feedback. Don't forget to share them in the comments. Thanks for watching. I'll see you in the next video.